Good morning, students. This morning I would like to explain section 11.4. Section 11.4 is a very complicated section. You're going to have to really pay attention and take your time to go through this assignment. It begins on page number 807. Please turn to page 807. I need you to notice some terms here. At least one of them we have not seen before. First of all, we have a figure on page 807 that is a pentagon, a five-sided figure, and they have defined some terms for us that I've also shown in my notes. The first thing that we see defined on this page is the term radius. The radius goes from the center of the figure to the vertex. Vertex, of course, is where any two sides meet. I've shown the same thing. I have a center, point O here, all right, and the radius goes from O to A or from O to B, okay, or from O to C. OA, OB, and OC are three vertices that are pictured in my figure of a triangle within a circle. So O to A is one of the radii, O to B is the second radii, and O to C is the third radii. What is a radius? A line that goes from the center of a figure to the intersection of two segments. All right, so we have, for example, radius OA intersects A, which is the intersection of the lines AC and AB. In my figure, I have three green lines. Those are called apothms. This is the new term for this section. The apothem is defined as a segment that goes from the center to the 90 of any side. So I've got pictured here OD, that's an apothem. OF is an apothem, and OE is an apothem. What's an apothem? An apothem is a line that goes from the center to the 90 of any side. Of course, the 90, at the 90-degree angle that is, that point is the shortest distance from the center to the side. So OD, OE, and OF are three apothms. And then we also have here a central angle. So for example, in my diagram, angle BOC is a central angle, AOC is a central angle, and AOB is another central angle. What is a central angle? An angle that includes the center of the figure and two consecutive vertices. The context of this assignment is that all the polygons that we find the area of will be regular polygons. What is a regular polygon? A polygon in which all the sides and angles are equal. Now the formula that we're going to be learning for this section is as follows. The area of a regular polygon is 1/2 of the apothem multiplied by the perimeter. So again, multiply 1/2 by the apothem by the perimeter. So I have here pictured, first of all, a red hexagon. Its center is O, and let's imagine that we know that the length of OA is 6 units long. I have a regular hexagon. That means all the sides are equal. AB equals BC equals CD, and so on. It also means all the angles are equal. For example, the central angle FOA equals the central angle AOB, and so on. So in my regular hexagon, I have been given that the distance, the radius distance, OA is 6, and I need to find the area. Well, of course, the formula tells me that the area is 1/2 of the apothem times the perimeter. So I need to find the apothem, OG, and I need to find the perimeter. All right, and I'm only given OA. So what I've done here is something that you might find useful for each of the problems you do today. Just try to split the figures into a particular triangle. Try to split the figures such that you're looking at just part of the figure. So I'm going to focus on just the part OGA. OGA. That's the only part I'm going to be looking at here. OGA. All right, so I'm going to be looking along here. OG, GA, and OA. And I drew that triangle down here, OGA. Now, first of all, OG is an apothem. It goes from the center to the perpendicular of the side AB. And AG, of course, is part of the perimeter. In fact, if there are 6 lines for the perimeter, like the line AB, then AG would be 1/12 of the perimeter. All right. Now, in order to solve this triangle, in order to find the parts of this triangle, I'm going to have to use some trigonometric functions. So, for example, to find OG, I will say that the cosine of 30 is OG divided by the hypotenuse 6. Now, how did I get that this is a 30-degree angle? In other words, how did I find that angle AOG is 30? Well, all the way around the circle, all the way around this circle here is 360. And this part is 1/12 of that. All right, 1/12. Why 1/12? Well, there are 6 sides. Each central angle is 1/6. So, for example, central angle AOB is 1/6 of 360. So half of that, AOG, is 1/12 of 360. So I know that that angle in the center there is a 30-degree angle. So cosine of 30 degrees, cosine of this angle up in here, and let me show that in red just a moment. Cosine of this angle here in red is equal to the adjacent side, OG, divided by the hypotenuse 6. Doing the trig, I will find that OG has a length of 5.19. So that's my apothem, 5.19. So I plugged it in the formula there. The area is 1/2 of the apothem, 5.19, times the perimeter. How are we going to find the perimeter? Well, let's find AG. All right, the sine of this angle, 30, the sine of it is the opposite side divided by the hypotenuse. So the sine of 30 is AG divided by 6. If you do the math there, you will get that AG is 3. All right, and that 3 is 1/12 of the total perimeter. AG is 1/12 of the total. So 3 times 12 is 36. I plugged that perimeter in right there. So the formula says the area of the figure is 1/2 of the apothem, 5.19, multiplied by the perimeter. I'll find that the area is 93. All right, we're going to be doing problems 1 to 20. These problems are going to take you a bit of work. They are rather complicated. You are free to call me or listen to this video again. So let's take a look at some specific problems. I'd like you to go to page 811, and I'd like to explain number 2. Number 2 is a triangle in which one of the sides is given as 6 units long. What I did is I pictured that triangle. I flipped it up on its side a bit, and I labeled it ABC. And I said, okay, if AC is 6, that's what's given on page 811, number 2, then DC is 3. DC is 3. So I made a right triangle out of this, BDC. All right, and I know